All right, let's look at how to turn a word problem into a piecewise function. We're going to do this two ways. There are two different videos. This video is going to look at using a table to work on finding the piecewise function. The other video looks at using the graph to do that. So either one is fine to watch, and whichever works best for you is great. So it says a data plan for a smartphone charges 99 cents per day for data usage up to 20 megabytes, and then 7 cents for each additional megabyte after the 20. Right, a piecewise function for the daily cost C of the data plan is a function of the number of megabytes M used. All right, so let's start by identifying our independent and dependent variables. Since it says C is a function of the number of megabytes, that means C depends on the number of megabytes. So my dependent variable is C, the cost, and my independent variable is M for those megabytes. And then we need to look at kind of setting up a domain in our table here. So what values could M be? Looks like the smallest to me that would make sense for the number of megabytes would be as if you didn't use your phone at all that day. So you use 0 megabytes. And then it stays constant at that 99 cents for the first 20. And then after that, it changes. So let's make this table go by fives, I guess, would probably be a pretty decent plan. So 0, 5, 10, 15, 20, 25, 30. The problem says for the first 20, it's going to cost us a fixed 99 cents. So 99 for each of these. Okay, and then after that, it's going to go up by 7 cents per megabyte. Okay. So here we jump from 20 to 25. So we added an extra 5 megabytes at 7 cents each. So that would be 5 times 7 plus the 99 from before. So that gives us 134. And then if we repeat that process, we get 169 cents over here. So $1.69 if you were using 30 megabytes. Okay, now that we have this table, we can see that there are kind of two distinct parts here. So our piecewise function will have two parts to it also. So our piecewise function is going to be C of M. So that's our dependent variable, and there's our independent variable. If you use X and Y, right, we traditionally call this X and this one Y, that's fine. Just identify that you're using X to represent the megabytes and Y to represent the cost. Okay. All right. So that first part is really easy. It's that fixed flat 99 cents. So the function is just equal to 99 cents for megabytes between 0 and 20. Okay. And then once we get over 20, so if our megabytes are more than 20, then we have a little bit different formula here. All right, we're going to use point slope form because we know this is our slope. And then we can use any one of these points. And I'll just use this first one here. All right, so I'm going to write our point slope form. Y minus y1 is equal to the slope times x minus x1. And then I'm going to convert this into our variables here so that we're kind of staying consistent with this. So y is the same as c. So c minus c1 is equal to my slope times my x is represented by m. So m minus m1. So I have my slope and my point. So c minus 134 is equal to 7 times m minus 25. And then if all you were doing was finding this one piece, I'm fine if you leave your linear functions this way. But because it's piecewise, we do need to say c equals. The easiest way to deal with that is just to add that 134 over to the other side. So you have c is equal to 7, m minus 25 plus 134. And if you put that in here, that's totally fine. I would absolutely take that as an answer. If you want to clean it up a little further, you would get 7m minus 41 if you distribute this and then combine that like term. So put that 7m minus 41 here. So now we have found our piecewise function. And then it says identify the domain and range. So the domain is all the values of the independent variable that we're allowed to have. So we decided our smallest value is 0. And this thing really looks like it could just keep going and going. So our domain, I have m is greater than or equal to 0. there's probably some sort of logical cap there. And you can't use an infinite number of megabytes in a day, but I'm really not sure, and the problem doesn't give us any information. So we'll just state what we know, which is the number of megabytes needs to be greater than or equal to 0. And then for the range, we're looking at the values of the dependent variables, the values of the cost. The smallest value looking at this table is 99, and then all the values from there are going up. So similarly to how we did the megabytes, I'm going to say that the cost is greater than or equal to 99. Okay, it's not infinite. I mean, gosh, I hope I don't have an infinite phone bill. There's probably, again, some sort of reasonable cutoff, but we don't have that information. So we'll just say that the smallest you can pay is 99 cents, and it goes up from there.